Alright, so now let's look at these equations with one variable, and they have unique solutions that I will show you. So, you got this expression, and if you remember from the last slide, our first step is to simplify, right, each side of the equation using PEMDAS. Alright, so let's do parentheses first. Quantity 12 plus 2 is 14. And then n times 6, quantity 6 minus 2 is n times 4. And if I use the commutative property, right, I could switch this 4 and this n. Like that, because it's n times 4 and 4 times n is the same thing. Alright, we can see that this is the same like terms. So, try second step. I want to do SADMET. Okay, because I can't simplify each side of the equation anymore because they're not like terms. So now let's try to move some numbers around. Alright, and I want you to show you something where I try to move this n to this. They're positive. I'm going to subtract them to cancel out. But look, they cancel out, and then they're both gone. And now all I'm left with is 14 equals negative 9. Hold up, is that true? No. No, 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 no. Not true. Okay? Not true. So this is a very unique circumstance where this answer is no solution. Alright? Because if I plug in any number, oh, my pen's being funny. If I plug in any number for n, so let's draw it back here. Alright, if I use like n equals 2, right, and I plug it into like, back into this original equation right here, okay? So I have like 4n, so 4 times 2 minus 14, and then 4 times 2 minus 9, okay? So, 4 times 2 is 8, okay? But it will always have a minus 14, right? Over here, we'll always have a minus 9. So this side, right here, will always be 5 less than this side, okay? Because this is throwing it off right here, right? If you plug both with the same number n. So when you have the two variables kind of cancel each other out when you try to find the variable, that is no solution, right? Because this means that both sides of the equation do not equal each other. They do not match up. Right? So here's a quick explanation of why that is that. Alright, so let's go ahead and look at this one, right? Once again, let's start simplifying the sides using PEMDAS. Alright, so let's say we got 8 divided by 4 is 2. So I'm going to do multiplication first before addition. And then, since you can't add these up, they're not like terms, I'm going to distribute 3 times k and then 3 times 32. That's going to be 3k plus, that is 96 minus 89. I'm going to now continue to simplify, so that's going to give me a 7, 3k, and then 3k plus 7. Okay, interesting. So I'm in the same predicament right here, where if I want to cancel a positive 3k, I'm going to subtract. Okay, 3k on both sides. And look, they both cancel out still, but I get 7 equals 7. Interesting. So both of the sides of the equation are exactly equal to each other, regardless of the variable. So I would say for this one, right, the solution is any real number. I can't spell. What the heck? Because, check it out. Let's say my k is 2 once again. Right? And I'm going to plug it back into this equation up here. So, if I have 7 plus 3, 2, right, I plug this into where k is. And then 3 times 2 plus 7. Right? I add them up, so that gives me like 13 equals 13. So any number I plug into the equation right here will always be true. So I could use any number, plug into this equation, and they will always equal on both sides. So I would say any real number is my answer. Computer's being laggy. Alright, so now try these next couple problems. And here is a quick explanation. Alright, go for it.